Good morning, all of you. Myself, Abhishek Kumar, representing an experimental study on concrete using waste rubber tire under the guidance of Mr. Asta Chaurasia, Department of Civil Engineering, kmclu, Lucknow. Presented by Abhishek Kumar, Arpit Srivastav, Abhishek Kumar Singh, Alok Kumar, and Dara Singh. Also, abstract. This experimental is efficient and economical in nature and are easily available. Experiments were conducted on concrete with the standard size of cube 150 mm into 150 mm into 150 mm with addition of various rubber quantities like 2.5 percentage, 5 percentage, 7.5 percentage, and 10 percentage. The investigation demonstrated a better improvement in the strength of concrete. Introduction: to utilize waste tire is very difficult these days. For solving this problem, tire is used in concrete as it is a good solution for environmental issue. A small quantity of cheap tire pieces can also do wonder in case of compressive strength when they partially replace either in fine aggregate or in coarser aggregate. Rubberized concrete. Rubberized concrete is the concrete in which coarser as well as fine aggregate is replaced by scrap tire rubber. Rubber is replaced in partially amount and helps in increasing the compressive strength of concrete. Rubberized concrete is a concrete in which there is a replacement of scrap, chrome, chipped or shredded rubber tire either at the place of aggregate or cement. Various studies have been discussed that rubber tire increase the strength of compression. Objective of this test. The objective of this project is to save the environment by using waste rubber tire and concrete to protect the earth. Rubber tire gives high compressive strength in concrete and use the hairs gives good tensile strength. Safe for environment, waste can be used for increasing strength and durable. Some literature review are included in this PPT. First is P.T. Sukon School in 2004. In the study, it was observed that pedestrian block of chrome rubber tire worked very well in skid resistance and abrasion resistance. In the study, the production method is cost effective due to ease of the production process. Next literature review are Sandeep Veeravati 2017. Here the reinforcement mixed with the tar rubber is fractional and cost effective way to resolve micro cracks and associated deficiencies. Fiber are commonly used for the plastic shrinkage control in concrete and dry shrinkage, cracking, and also to reduce the permeability of concrete. Some material are used like cement, fine aggregate, and coarser aggregate, water, rubber tires. So discuss in detail. Cement are used 43 grade, which is specific gravity are 3.15. Fine aggregate are used Indian Standard Specification IS 383 1970. Sand used river sand and approximately specific gravity 2.5. And next coarser aggregate. Coarser aggregate is crushed angular with maximum size of 20 mm for the 150 mm cube size. The specific gravity of coarser aggregate is 2.74. Water absorption of coarser aggregate is 0.6%. Water as IS 4562,000 of mixing as well as curing of concrete specimens. Tire rubber are used shredded, which size is 1.5 to 2 mm. As it is waste material and causing environmental pollution, we are using it partially replacement of coarser aggregate. Properties of material are used. OPC cement 43 grade, aggregate size 20 mm, sand coarser grade, rubber size 1 and 2 mm, grade of concrete M25, ratio 1:2, water cement ratio 0.42, 42%, quantity of material as per 3 blocks when rubber is partially replaced by 7.5%. Then material quantities are shown in next bullet point. Coarser aggregate 11.1 kg, fine aggregate 6 kg, cement 6 kg, rubber tire 900 grams. Quantity of material and their images are shown in next slides. Cement, sand, aggregate and shredded rubber tires. Test performed: slump test, compaction factor test and compressive strength test. Slump test is the most commonly used method of measuring consistency of concrete, which can be employed either in laboratory or at site of work. It is not suitable method for very wet or very dry concrete and steep mix. Slump test is performed for maximum size of aggregate is 38 mm only. Slump value for very low, low, medium, high and very high concrete. Next, compaction factor test. The compaction factor test is carried out to measure the degree of workability of fresh concrete with regard to the internal energy required for compacting concrete. Those roughly, the compacting factor test is used to find out the low workability of concrete. It is a fact that the slump test of concrete is not given accurate result for the low workability of concrete. Then the slump is greater than 50 mm. Next PPT shown in the compaction factor test image and partially compacted and fully compacted image. Result of compaction factor test: weight of partially compacted concrete 12.59 kgs, weight of fully compacted concrete 13.064 kgs, compaction factor 0.963. This value used for heavy construction work. Water content 200 2687 grams. Cement contains 6,000 grams. Water cement ratio 45%. And third and last test or compressive strength test. Compressive strength is the ability of material or structure to carry the load on its surface without any cracks or deflections. A material under the compression tends to reduce the size while tension size elongated. For cube test, two tests of a cement either cube of 50 centimeter, 50 centimeter into 50 centimeter, or 10 centimeter, 10 centimeter, 10 centimeter, depending on the size of aggregate are used. For most of the work, cubical mold of size 50 centimeter used. These specimens are tested by compression testing machine after 7 days curing or 28 days curing. Load should be applied gradually at the rate of 114 kg per centimeter square per minute till the specimen fails. Load at the failure divided by area of a specimen given the compressive strength of concrete. 190 million used tires are generated in India every year. Graph of generated rubber tire every year. This number are also increase year by year. Last year 2022 this ratio are increased to 50 millions unit of rubber tire. Of those 190 million tires in India each year, only 10% are recycled and nearly 30% are exported for reuse processing or as tire derived fuels. The remainder are stockpiled, legally dumped in landfill or illegally dumped. Methodology of the test to study the interaction of tire rubber with concrete. Experiments were conducted on 15 cubes. Each group consists of 3 cubes of size 150 mm. The first group is flattened concrete with 0% rubber by weight of coarse aggregate, second 2.5%, third 5%, and fourth group consisted 7.5%, and last of fifth group consisted of 10% rubber by weight of coarse aggregate. Cement is added to the sand and mixed thoroughly by hand to get a uniform color. The coarser aggregate and rubber is spread on ground and is mixed with cement sand mixer to get a uniform distribution of the mixture. For casting of the cubes, standard cast iron metal mold and size 150 mm cubes. After mineral oil is applied on all sides of mold, thoroughly mixed concrete is filled in the mold in 3 layers of equal height followed by tamping using a rod of 60 mm diameter. Then the mold is placed on table vibrator and the excess concrete is removed from the top layer. Compressive strength test results are shown in the below of compaction test. Percentage rubber content 0%, 2.5 and 5 and 7.5 and 10 percentage. Date of costing 30, 50, 70, 80 and 90. Date of costing, date of testing 20, 22, 24, 25 and 26 of April. And weight reading in kilonewton in compressive strength in stress term, Newton प्रति mm square. R at 7 days 60.51, 70.2, 80.23, 90.78 and 80.14 Newton प्रति mm square. In next 40 days compressive strength test and next compressive strength test at 40 it is 0% पे compressive strength 24.88 kg Newton प्रति mm square 25% पे increase value increase 25% पे value also increase up from 2.5 percentage 7.5 percentage or maximum value maximum compressive strength get final results final compressor result of percentage 7.5 percentage of 28 days strength 29.78 Newton प्रति mm square. Experimental works materials cement, fine aggregate, coarser aggregate, water, threaded rubber tires. Merits affordable and cost effective, can withstand impact and high pressure, good resistance to water because it absorbs less, resistance to acid, low unit weight, resistance to abrasion, ductility and lightweight concrete are gates. Conclusion of this test results are shown in next bullet point. This is found that there are positive result and decrease in the properties of PM25 grade of concrete according to the percentage of rubber by weight of gross concrete. The experimental analysis showed that the optimum content of rubber to be applied in the M25 grade of concrete was 0%, 2.55, 7.5 and 10% as M25 concrete is combined with 3% rubber in constructed with pure concrete. There is 12-30% increment in compressive strength when rubber tire is shaded with various percentages. According to the result of the experimental analysis, the optimal content of rubber to be applied to M25 grade concrete is 7.5%. There is control in cracking, improving swelling resistance and substantial reduction in cracks width. Reference of rubber tire partially is coarser aggregate. First reference is NN Eldane ASCE General Volume 4 .478 slash 496 1993. Second Pandakeshi. Third Renju Pillai and Ayothriman Ramanathan. Fourth is Sandeep Yerabati. Fifth is Dr. Sinan Abdul Yashin. And sixth reference is Parul and Bansals. Thank you for PPTs.